two important concepts in terms of counting. They are permutation and combination. Permutation and combination. They're similar and they're different. All right, now what does that mean? Let me give you I'll give you the choose R out of N. How many ways? That's you try to solve, all right? Now, for combination and a permutation, the difference is this one, we call this a permutation, choose R out of N. Okay, so see the way we write it? The N smaller to the right and the N out of the N number. So that would be N factorial divided by N minus R factorial. And we already learned what is a factorial. And this one, the combination is a C. We choose R out of N, and I give you the formula first, and I will explain the difference later, okay? So there will be N minus R factorial and R factorial. They're different, right? And what's the difference? What's the difference? This one, order doesn't matter. And in this case, order matters. Okay, so that's a major difference. For example, let's say in our class we have 20 students, and then I need to choose 3 as the sample, as my sample, and then I need to let them, not the sample, I'm sorry, I choose 3 out of 20 as the representative of this class, and form something called a committee. Let me just randomly choose 3 out of 20, form a committee. All right, if for this 3 student I choose out of 20, there are others. If the first one is going to be the chair or president, and this is the secretary, and the third one is a treasurer. So if the first one I select, and the second, and the third one select, there's a difference. Which means orders, which means this, right? Matters. So there's an order matters. Who else in the first? Whoever gets chosen in the second, they're different. Okay? And this one, order doesn't matter with situation, like if I just want to choose out of 20. However, it doesn't matter the order of being chosen. You get choose the first, choose the second, or choose the third. It doesn't really matter. So I just need it of 3. In that case, we're going to use the combination. So that's how many different committees could be solved. Okay. So that is the difference. For example, and I give you one quick example. In horse race. A trifecta bet is won by corrected, here, example 1. Okay. Correctly selecting the horses that finish first and the second and the third. You have to mark. This is my first choice. This is my second choice. And this is my third choice, right? Because you have like a 20, you have a horse 1, 2, and also 20. So all the way there. And then so you're going to choose who will win first, who will win second, who will win the third. So they get all the circles, and then you just need to use a pencil to mark. Let's say I think this, the second, and this will be the third. Let's say that's your choice. How many different choices are there? Okay, so you select them in the right order, then you win. Okay, so how many different ways that you can make the selection? or how many tickets you want to buy if you want to submit all different tickets. So that we're going to use the P, choose 3 out of 20 because order matters. When order matters, we use permutation. So the formula will be 20 factorial. Did you see that? The permutation choose r from n. When order matters, it's going to be n factorial over n minus r factorial. So n in this case is 20, right? N is 20. Okay, and r is 3. If you couldn't remember that, you can just write it down. And then here will be 20 minus 3 factorial. We have to find it. You cannot just give to me like this as your answer. So you're going to write, you know what I do? I write the denominator first. Because 20 minus 3, which is 7, so I write 17 factorial. 20 minus 3, it's 17. So I write a 17 factorial. And in the numerator, I write 20 times 19 times 18 times, hey, when I reach to 17, all the way from 17 and below, I don't need to write that. I just need to write a 17 factorial because I can cancel them. Even you want to write a 17 by 16 by 15 and all the way to 3 to 1, you're going to cancel that with the denominator too, because the denominator is also 17 by 16 by 15 and all the way down. So your answer here will be 20 times 19 times 18. Oops, 18. So that will be much, much easier to get the answer. So 20 times 19 times 18. So the answer is 6840, which means if you want to buy all the possible outcomes, then you're going to spend this much. You're gonna buy this many tickets. That's how many tickets. Okay, now this is the situation when order matters, because you're gonna choose which one is the first, which one is the second, which one is the third, right? What about the lottery ticket? Let me give you a simple lottery ticket question, which is our example 2. All right, a simple lottery ticket. If I just give you just the number from 1 and 2 and 3 and 4 and 5, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Each one has a circle, okay? Just a circle. This is a simple version of a lottery tickets. Okay, and on the right side I have a 1, 2, 3, 4, 5. All right. It's a simple version of the lottery tickets. Let me ask you, how many combinations are possible if you're going to choose a 3 plus 1? What it means is, for all those 15 numbers, for the first part, I ask you to mark 3 of them. Choose a 3 out of a 15, and then choose 1 out of a 5. Okay, you're gonna see this type of a very, very similar type of a lottery tickets in like a Powerball, or what's the other one? Mega Million. Very similar. Okay, so how many possible combinations are there? First of all, I'm gonna choose a 3 out of a 15. Does order matter? If you choose 12, 9, no repeats, right? 12, 9, 15. Is that the same as you choose 15 first, then 9, then 12? No. So in this case, order doesn't matter. You see that order doesn't matter, we use combination. So you remember C and R, which is n factorial, and here is the difference factorial and R factorial. In our case, in this case, n is 15 and r is 3. So we do choose 3 out of 15. That will be the 15 factorial over, here is the difference, n minus r. So n minus r, I just write 15 minus 3 factorial and r factorial 3 factorial. All right, I can go ahead and do that. So again, I always do the denominator because that will make me get some sense that where I can stop on the top. So 15 minus 3, which is 12 factorial. And the other one, I just write it, 3 by 2 by 1. This is all multiplication. The top, I get a 15 by 14 by 13, and then when I go to 12, I just write 12 factorial because I can easily cancel them out. And then if you like, you can just use a calculator to find out what's the top and what's the denominator and then do that. Or you can do further simplification, like you can cross out this 3 with this 15 and you get a 5 to get rid of the common factor. And then for this 3, this 2, you cross out with this 14, you get a 7. So you need to do this. You need to do 5 by 7 by 13, and that is 455. Okay, so far that's how much different possible choices you can have from the first part. And what about this part? Choose 1 out of 5. How many options? 5. It's very easy. Or you can do, because you only choose 5, so we don't care about the order. So you can either use a P or C, doesn't matter. So, or you can just quickly give me, there are 5 options. So 455 different ways to choose the first part, 5 different ways to choose the second part. Now we go back to the multiplication rule. Multiplication counts how many different ways you choose the first part, how many different ways you choose the second part, and then you multiply. So the answer will be 455 times 5. Okay, there will be 2,275 different possibilities for this easy, simple version of a lottery game. All right, so then what is the chance that you're going to win it? There's only one winning number combination, so the chance of win, if you just buy one ticket, chance of win will be 1 out of 2275. It's fairly small. Now, as the extra exercise, you go to 7-Eleven or Walmart or somewhere that they sell the lottery ticket, ask for a blank one. They're going to give it to you. So you ask for a blank one, and then you're going to find out, like, how many different combinations are there, and then figure out what is the chance that you're going to win this ticket. Okay, so yeah, have fun. But make sure that you do this, I guess, when you're over, I believe, 21 years old, you can do that. Okay, so this is pretty quick, but I want you to remember this. Permutation, combination, you're going to choose R out of N subjects, and how many different ways of this different ways to choose R out of N, it really depends on whether the order matters or not. If order doesn't matter, use combination. If order matters, use permutation. Okay, so that is the, I think this is fun.